Okay, well apparently I forgot to do this extra sheet here, so I'm going to do it right now. We have the change in y here that I calculate for each one of these tables. As a reminder, change in y is always equal to y2 minus y1. We are always doing the second value minus the first value. So we have second value minus the first value, that is to say negative 6 minus negative 3. That's going to go ahead and be negative 3. Negative 7 minus negative 6. That's going to go ahead and be negative 1. Negative 6 minus negative 7. That's going to be positive 1. Negative 3 minus negative 6. That's going to be positive 3. And finally, 2 minus negative 3. That's going to be positive 5. So the change in y, all you really got to do is do this one more time. Negative 1 minus negative 3. That's 2. Positive. 1 minus negative 1 is positive 2. 3 minus 1, positive 2. 5 minus 3, positive 2. So the point of doing any one of these tables is to answer a question about its concavity. It is to say this guy has a concavity of 2. But more importantly, it is concave up. Or in other words, it has positive concavity. Positive concavity are happy functions. They have minimums down here, and then they go up forever on the other sides. And we know that this function is quadratic because the concavity is constant, because the change in y is constant. So we are quadratic because delta delta y is constant. And the graph table A would have positive concavity over the given input values because 2 is a positive number. Really, there's not much to it. You're just trying to figure out, if this is positive, it's got positive concavity. If it's negative, it's got negative concavity. Please note, some functions can actually change concavity, but that's kind of later in your mathematical future. Okay, now we're actually done.